Space is not empty but filled with a superfine form of matter generated by mass defects throughout the universe. This insight transforms our current understanding of the cosmos.
Joseph George's theory explains length contraction through interactions with an ultrafine, pervasive form of matter he proposes fills the universe. This contrasts with the framework of special relativity, in which length contraction arises from spacetime transformations. He suggests that this space-filling matter is generated by mass defects, a phenomenon universally occurring in events like active stars, supernova explosions, neutron star collisions, and black hole mergers, permeating space across the universe. Here's an outline of his theory's approach to length contraction. 1. Length contraction as physical compression due to resistance from space-filling matter. In George's model, objects moving through space-filling matter encounter a resistive force that intensifies with increasing speed. This resistance exerts a compressive effect on high-velocity objects, physically shortening them in the direction of motion. Unlike in relativity, where length contraction is an effect observed from a different frame of reference, this is a real, physical phenomenon. 2. Space-filling matter density and resistive drag. The faster an object moves, the more it interacts with the space-filling matter, accumulating or displacing it as it accelerates. This interaction applies pressure, compressing the object in the direction of motion. Thus, the contraction in length is due to the resistance from space-filling matter rather than an observational effect resulting from differing reference frames. 3. Dependence on speed relative to space-filling matter. In George's theory, the extent of length contraction depends on an object's speed relative to the space-filling matter rather than on the relative velocity between observers. As an object approaches the speed of light, the resistive force from the space-filling matter increases significantly, leading to near-complete contraction along the direction of motion. This result aligns with relativistic predictions of lengths approaching zero as an object nears light speed, though here the cause is physical interaction with space-filling matter. 4. No frame-dependent transformation. In special relativity, length contraction is relative, depending on the observer's frame of reference. George's model posits that contraction is an absolute physical effect resulting from space-filling matter interactions, independent of any observer's frame. Thus, an object moving at high speed would experience a measurable contraction in its structure. Alternative to the Lorentz transformation, in special relativity, length contraction is described by the Lorentz transformation. L equals L0 scret, 1 minus frac V2 c squared, where L is the contracted length, L0 is the proper length, V is the object's speed, and c is the speed of light. George's model would aim to reproduce a similar relationship but attribute it to drag from space-filling matter rather than space-time geometry. The length compression would depend on the resistive force from space-filling matter, potentially resembling L equals L0, left frac alpha V2 c right, where alpha is a constant reflecting the influence of the space-filling matter. 6. Implications for observing length contraction. Since George's theory proposes length contraction as a physical effect, an object moving through space-filling matter would experience real compression along its direction of motion, rather than merely appearing contracted in another frame. This compression could, in principle, be measured directly as a change in the object's physical dimensions. 7. Unified explanation for other relativistic effects. George's theory suggests that length contraction, time dilation, and mass increase are outcomes of an object's interaction with space-filling matter. The faster an object moves through this medium, the more it experiences resistive effects, leading to time dilation, a slowing of time-dependent processes due to resistive drag from the space-filling matter. Mass increase, an effective mass increase resulting from accumulated space-filling matter within the moving body. Length contraction, compression along the direction of motion due to space-filling matter pressure. 8. Experimental implications and distinctions from relativity. If length contraction results from physical interactions with space-filling matter, experiments might detect physical stress or compression in materials moving at high speeds. For example, an object moving close to the speed of light might experience measurable mechanical effects or stresses within the material due to compression from space-filling matter interactions, which would not be predicted by special relativity. This could provide a means to test George's theory against the standard model. Summary. In Joseph George's theory, length contraction is not an observational or frame-dependent effect, but a physical consequence of moving through resistive, space-filling matter. As an object accelerates, it intensifies its interaction with this fine matter, resulting in compression along its direction of motion. This approach offers a medium-based explanation for length contraction, distinguishing it from the relative transformations in special relativity and suggesting a real, measurable shortening of an object's length due to space-filling matter resistance. This theory challenges the relativistic perspective by attributing relativistic effects to a fundamental role of space-filling matter.